Hi, in this class, we will discuss and learn about the laws of exponents for real numbers. It is not new for us to come across these laws or these exponents. We have dealt with them in our earlier classes, but now we will use these laws regarding real numbers. Okay, so now our scope has extended to real numbers. So instead of just performing this action or this operation on natural numbers, we will be applying these laws to real numbers as well. So let's start. Laws of exponents for real numbers. Okay, so first let's simplify some of the examples which we have already did. The operation which we already performed, and we know how to do it. So let's, for example, take this one: 17 squared times 17 to the power 3, or 17 cube. Okay, so how do we simplify this expression? We are not going to multiply all of them, but we just want to know what will it be. Okay, so it's like simplifying it. So we know that we just add these two powers, these exponents, and we get this 17 to the power 5, right? So when the base is the same, when the bases are the same, so we add the powers, we add the exponents. That's it. That's how we do it, right? Now for this one, let's say 5 squared raised to the power of 7. So what does it become? We multiply the exponents, right? And it becomes 5 to the power 14, right? So the simplified version of this expression is this one. Okay. So, and we also know how to do when it comes to division. So the rules which we have applied and which we know from our earlier classes are these. So a to the power m times a to the power n is equals to a to the power m plus n, right? So this is rule number one. And the another law was this: a to the power m and then again raised to the power of n becomes a to the power mn. And the third law is this: a to the power m upon a to the power n becomes am minus n. And in this specific law, we also have a condition, and that is m needs to be greater than n. The exponent in the numerator is greater than the one in the denominator. Okay. And the third one is this: a to the power m times b to the power m equals a times b to the power m, right? So these are just four laws which you already know, which you have already applied and used in your questions in the earlier classes. Now we will be extending these laws. So first, remember that whenever we have a number, let's say a, and a is a natural number so far, and the exponents m and n were also natural numbers. Okay, so whenever there is a number, let's say a natural number, and it is raised to the power of 0, what is this equal to? This is equal to 1, right? It equals 1. And why does it so? So for example, let's take this case where we have 10 squared upon 10 squared. So one way to look at it is in terms of exponents, right? So what do? We take this minus this, and it becomes 10 to the power 0, and it comes out to be 1 as per the rule, as per the law. But if you write it, if you expand this expression like this, 10 times 10 upon 10 times 10, you can see that we cancel out all these 10s and we get 1 at last. So as you can see, these two results are the same, and they should have been same as well. So this is how it works. So that's why we take for any number, if the power is 0, the answer is 1, right? So now we will extend and we will apply this thing to derive this result. What happens when we have so using that thing, we will get this one: a upon a to the power n equals a to the power minus n. Why is it so? because a can be written as a to the power 0. This 1 can be written as a to the power 0 upon a to the power n, and it becomes 0 minus 0 minus n, using the law of exponents in terms of division, right? So it becomes a to the power 0 minus n. So it can be written as a to the power minus n, right? So that's why we say, or you can conversely you can say that a to the power minus n. So this is now negative exponent. So a to the power minus n is a upon a to the power n, right? 1 upon a to the power n. So now we will be handling these negative exponents as well, right? So now we have got a way to express or to interpret this negative exponent. So now we will we'll get these we'll apply these laws to the real numbers as well. We'll include those real numbers. Okay, so if you are given something like this, 17 squared times 17 to the power minus 5, and it comes out to be 17 to the power 2 plus minus 5, which is 17 to the power minus 3. So it becomes 1 upon 17 cubed. Now you know what 17 cubed is, and so this is just a simple rational number. But manipulating or interpreting this thing into this is important, right? Okay, so let's do this one. Now we'll talk about nth root of a. Let's say a is a real number, okay? A is a real number. Then nth root of a is b. It means that if nth root of a is b, then it means b to the power n equals a. So nth root of a will be b if that b after getting raised to the power n gives you a. Okay, only in that condition nth root of a becomes b. Now we can also interpret this nth root of a like this. In this way, nth root of a can be written as a to the power 1 upon n, right? So in the language of exponents, in terms of exponents, we interpret this thing as this, right? Nth root of a equals, so you have to remember this expression and we will be using it, right? So now we have those 4 laws, and now just we have extended those laws to real numbers, and the exponents will be will not be just natural numbers but also rational numbers, okay? So let's solve the questions and see how do we apply these laws. So exercise 1.6, question number 1. So we have these 3 numbers, 64 raised to the power of 1.2. If you look at it, we will first write it in this way: square root of 64. So 64 or any number to the power half means square root of that number. So you know square root of 64 is 8, right? So it comes out to be 8. And the second one is this: 32 to the power 1 upon 5. So it means that fifth root of 32. What is the number? So fifth root of 32 will be some number. What is the number when being raised to power 5 gives you 32? So that number is 2. You will have to do some trials and errors to get this result. So the answer is 2. Now the third one: 125 to the power 1 upon 3. Now it is asking us to find cube root of 125, and that is nothing but 5. You know this. So 5 cubed is 125. So cube root of 125 is 5. Okay, so yeah, just 3 questions. Now the second one, it has 3 numbers as well. So 9 to the power 3 upon 2. So first we will write this rational number, which is the exponent, in such a way that it becomes easier for us to handle this. Now we can write this as this. So we know that we can multiply this exponent with this to get this. So I have split this exponent into these two rational numbers. So now we know that first we will solve the thing which is inside the brackets. So 9 to the power 1 upon 2 means square root of 9. So it is 3. And then 3 cubed is 27. So this is how you find or simplify this expression. Find the not the value but find this one, right? What does it mean? So it means 27, just a number. So 9 raised to the power of 3 upon 2 is 27. Now the second one, 32 to the power 2 upon 5. What is this? Let's first we will do the same. First we take 1/5 of it is not, but 32 is raised to the power 125, then it is multiplied to the power 2, multiplied by the power 2. So we know we have just calculated or found what fifth root of 32 is. It is 2. So 2 squared becomes 4. So 32 to the power of 2 upon 5 is 4, right? So this is how we find these numbers. Or simplify, you can also say we are simplifying them. They are already numbers, but we are just simplifying to get the reduced form of it. Now second question, third part, and it asks us to find this 16 to the power of 3 upon 4. So first we will calculate fourth root of 16 and then raise it to the power of 3. So fourth root of 16 is what? 2. Yeah, so 2 to the power 4 gives you 16. 2 times 2 is 4, times 2 is 8, 2 times 16, yeah, 2. And then 2 raised to the power of 3 gives you 8. Yep, 8 times 2 is 16. And you can also go with this as 16 cubed then 1/4. But this will become a little bit more difficult to calculate. So that's why we first, find the number. We ensure that this number becomes smaller so that we can deal with it, so we can handle this easily. And the fourth one says this 125 raised to the power of minus 1 upon 3. We know that to remove this negative sign, we just write as the reciprocal in the reciprocal form, and it becomes 125 to the power 1/3. And it means cube root of 125. So we know that it is 5. So it comes out to be 125. 105. Okay, now the third one. Now we have to simplify these expressions. So 2 to the power 2 upon 3 times 2 to the power 1 upon 5. So what do we do? So these two are being multiplied. So we just add the exponents. 2 to the power 2 upon 3 plus 1 upon 5. And it is 2 to the power 15. And 3 times 5 times 10, 13. Yeah, it will be 13 upon 15. So it will become 10 upon 10. 3 times 5 is 15, 5 times 2 is 10, plus 5 times 3, yeah. So it will be 13 upon 15. Now the second one. 1 upon 3 cubed to the power 7. Right, so how will we do it? So remember that we are going to write this expression 7 times. So it is like, yeah, we know that this is repeated multiplication. So what happens is that this power gets distributed to these, to both the numerator and the denominator. So it will become 1 to the power 7 upon 3. So it will become 7 times 3 is 21. So 1 to the power 7 is going to be 1, 3 to the power 21. This is how it is going to look. And we can also write them as in the form of a negative exponent. Yeah, so we can write it. And we should, I would say. So we write it like this: 13 raised to the power of minus 21, right? So you know how to go from here to here. Now let's solve the remaining ones. So the third one says 11 to the power of 1 upon 2 upon the same base to the power of 1 upon 4. So you know what we are going to do? We will subtract uh, the exponents and we will get this. So half minus 1/4. So 1/4 is half of, yep, so it is going to be 4 and 2 times 2 is, yeah. It is going to be 4 and minus half. It is going to be minus half, right? So it is like 1 upon square root of 11. That is not the correct thing. So it is going to be 11 to the power 1 upon 4. And then we are going to solve the last one. And it says that 17 to the power half times 8 to the power half. So you know what? So it is written like this: 17 times 8 to the power half. So it is 56 to the power half. Yeah. So that is how we simplified it. So this was your exercise 1.6, and from now on we have completed the chapter named number systems, and we have learned about real numbers. Basically, we have included and we have now entered the mathematics which talks about real numbers, where numbers are not just 1, 2, 3, 4, but we also got to know about irrational numbers like square root of 2 and pi and 0.10, 110, 1110, like these. So yeah, the scope of numbers has expanded in itself. Okay, so thanks for watching this video, and if you have any doubt regarding it, type it in the comment section. Thanks.